Hey YouTube, this is a video on linear search, and here I've written down the definition. It says linear search or sequential search is a procedure for finding a particular value in a list that checks each element sequentially until the desired element is found or until you reach the end of the list. So linear search, also sometimes referred to as brute force search or sequential search, like I said here, is one of the simplest search algorithms. It starts with checking if the first element of a list matches the target and continues on for each element of the list until a match is found or until you reach the end of the list. So I'm going to just explain it here a little bit of how it would work. So let's say we had a list like this, and it's a list of random numbers or 5 elements, and these elements are each numbers. So I will say 5, I put 8 here, maybe 10, 11, and 100. And now we want to find the element 10. And we can see the element 10 is here, which is in index, let's see, this is index 0, index 1, 10 is in index 2, 3, 4. So we can easily see that it's in index 2. But how does a computer know? Well, this is how a computer would check this list using linear search to see if 10 is there. It will say, okay, I start here at the beginning of the list. What element is in this index here, index 0? Well, it's the element 5. Then it'll say, well, does 5 equal 10? And then the answer will be no. And if the answer is no, it'll move on to the next one. So it moves here at index 1. And it looks at the element in index 1. They see 8. They say, does 8 equal 10? And no. Then it moves on. It goes to index 2, where it finds element 10. And it says, does 10 equal 10? Yes, 10 equals 10. So now I found the number 10 at position 2 of this list. And so now the search algorithm can stop. So how would this look in code? Well, to do some pseudocode here, you basically are going to have your integer target. In this case, our target is 10. So I'm going to set target equal to 10. And then we're going to have a list, and you can think of a list like an array. And so I just say we have an integer array, and it's of size 5 because there's 5 elements. Okay, and so what we're going to do is we need to run through this list here. So we're going to also create another integer value called I for index. And then I probably should have left some room here. Actually, I will rewrite this up here. So integer target, that's going to be 10. We're going to have an integer array of size 5. And then we're going to have an integer variable called I for index. Okay, so now I can get rid of this down here. And so we want to run through the list. So from I equals 0 to I less than the number of elements in the array. In this case, it's going to be 5. And then we're going to increment I by 1 each time. And now, within this loop, so this loop here is going to run 5 times. It's going to run from I equals 0 to I equals 4. So that's 0, 1, 2, 3, 4. That's 5 times, right? Could you 1, 2, 3, 4, 5. Okay. So we want to find that element 10. So what we want to do is we want to check each index of the array. So we're going to have a condition or an if statement. If the array at position I, because remember I is going to be 0, 1, 2, 3, or 4, equals, that's just to say that it is equal to our target, which is 10, then we'll do something like return true. So we're going to say we found the element in the list. And so now this loop right here will do exactly what we want. It will do a linear search. It'll look at index I at position 0, and then it go through it, see it's not there. I will increment by 1, and now look at position in array 1 and see if it's equal to the target, which our target is 10 again. And it will see 8, and then it go through again, it'll see 10 eventually, and then it will return true. And then if it doesn't find it in here, maybe we'll return false, that it wasn't in the list. In this case, 10 is in the list, but if we were looking for an element like 55, 55 is not in this list, so it would go through all of the elements and we would never find it. So this is some pseudocode here that you can write in a function. Now, so then what's the worst time of this? Well, in the worst case, we find the element at the end of the list. So if we were looking for element 100, we'd go through the whole list. So we go from here, look for 100. Let's say does 5 equal 100? No. 8 equal 100? No. 10 equal 100? No. 11 equal 100? No. And then we find 100 here. So we went through 1, 2, 3, 4, 5 elements in this case. So in this case, the worst time would be big O of n, because we go through n elements and n happens to be 5. So the worst case is big O of n, because we never know how many elements are in the list here. It could have been 55. It could have been 65, 100, 1,000, a million. So this linear search algorithm is one of the simpler ones and easy ones to get done, but it's not always the most effective one. And some of the reasons why you would want to use a linear search algorithm is because if you're using a relatively small list, you know, who cares if it just, the worst case is 5 or 10, because the computers are so fast it doesn't matter. But for a really, really big list like 1 million or 2 billion, we're going to need something a bit faster than this. So all right guys, thank you very much, and please subscribe. See you guys in the next video.